top European industrial teams with decades of experience.
It will map the surface of the planet systematically and on a global scale, over and over again.
During a single acquisition, CHIME will acquire 4 times more data than any other hyperspectral satellite.
And CHIME will provide this data globally and on a systematic operational level for the first time in history. The Copernicus Hyperspectral Imaging Mission for the Environment, or CHIME for short, is an ESA mission that will provide routine hyperspectral observations of land and coastal areas for the Copernicus program. It has been designed to support European and global policies for the management of natural resources, with a focus on soil productivity, raw materials exploitation, and the sustainable use of fertilizers and water, food security and biodiversity management. I am Marco Celesti and an optical mission scientist. In particular, I'm the mission scientist of CHIME and Sentinel-2 Next Generation. The use of agricultural pesticides and fertilizers has expanded massively during the past decades. So global demands for natural resources such as water, energy, and food continue to increase. According to the Food and Agriculture Organization, global agricultural production will need to increase by 60% by 2050, and this just in order to meet the food demands of the growing global population. This can cause adverse effects on biodiversity and can cause also widespread pollution through chemical contamination or eutrophication of freshwater bodies. And at the same time, our ecosystems are under increasing pressure. In the coming decades, 1 million species could face extinction if biodiversity decline continues not to be tackled. This calls for urgent action.
Compared to other hyperspectral missions, CHIME will allow a complete paradigm shift. Copernicus CHIME will feature a novel form of operational data acquisition. On board CHIME, there is an advanced hyperspectral imager that will be able to acquire images in 20 times more spectral bands than Sentinel-2. Think about it, 20 times more than Sentinel-2. Imagine the possibilities. My name is Jens Dieke. I'm the project manager for CHIME, the hyperspectral mission for Copernicus.
So in simple terms, hyperspectral imaging is a technique that uses advanced optical sensors to measure light in a wide range of electromagnetic wavelengths. Hyperspectral sensors can capture hundreds of different narrow contiguous bands in the spectrum with very high fidelity, allowing scientists and data engineers to analyze a vast range of colors invisible to the naked eye.
CHIME will have over 200 spectral bands, from 400 nanometer to 2500 nanometer. This means from the visible to the shortwave infrared at a spectral resolution of less than 10 nanometers. During a single acquisition, CHIME will acquire 4 times more data than any other hyperspectral satellite. CHIME's key features are the combination of a high-quality imaging spectrometer together with onboard processing capabilities, 2 technologies which are very sophisticated. The imaging spectrometer provides spectral and spatial information for all ground pixels with the same quality. This means that the image quality will be very uniform and reproducible, and the onboard processing using AI is adaptable depending on the ground scene, accounting, for example, for clouds. This is the first time any Copernicus satellite will have onboard AI capabilities. It is so important that we get this right, because this is crucial for data quality. Remember, we strive to capture the pure spectrum of light from the Earth.
Until a couple of years ago, we only had the first experimental hyperspectral missions, which could only observe a very small footprint, like small hyperspectral postcards from the planet. Today, the number of hyperspectral missions is increasing, but CHIME will bring an operational capacity into play. It will map the surface of the planet systematically and on a global scale, over and over again. We are moving from occasional ad hoc measurements to a global-scale stream of hyperspectral products, from prototyping to large-scale deployment.
CHIME will have a ground resolution of 30 meter and a swath width of 130 kilometer for a single satellite. On top of this, CHIME will be a 2-satellite mission. Also, the data quality will be unprecedented. Each ground pixel will be observed with the same quality of a high-precision imaging spectrometer. So the combination of large instrument swaths and 2 satellites allows unprecedented revisit times of 11 days, which is needed for the operational use of the data. Guaranteed, no matter what, on any point of Earth.
Imagine that you are a farmer trying to optimize your crop production. With existing Sentinel satellite data, you are able to monitor vegetation parameters to get basically a sense of how your crops are evolving over time, and also have some indirect indicators of crop state and health. With CHIME, you will be able to dig much deeper than that. For example, you will be able to track the distribution of specific soil nutrients and properties in different parts of the field with unprecedented accuracy. With this, farmers will make much more informed decisions about irrigation and fertilization. This information is absolutely essential for applying innovative agricultural practices for a more sustainable management of fields. CHIME products will provide information on crop types and crop health worldwide, this by measuring specific vegetation and soil properties. This is crucial to define the correct amount of fertilizers to be provided to the crops. Not too much, not too less, and more important, only to the areas that really need it. So this will reduce the overall usage of fertilizers, mitigate negative environmental impacts, and frankly, save money. Imagine you want to study forest resources at large scales. With traditional remote sensing, you can retrieve like the vegetation cover and some basic, though very important information about the health of the trees. With hyperspectral products from CHIME, you will be able to capture detailed information about the chemical composition of the leaves in the forest canopy, or discriminate different forest types, or even identify single plant species. You can characterize the overall health of a forest, its state of degradation, or its ability to absorb carbon. A real added value of hyperspectral remote sensing is that it is very versatile. In fact, the same CHIME measurements will also be used to map mineral composition and abundance, or to reveal information on water quality, or even to yield information on snow properties.
CHIME builds on experience of Prisma and Nmap. Here we are building on excellent heritage coming from national programs in Italy and Germany.
For mapping raw materials, CHIME will provide an in-depth mineralogical information. This is to support extractive industries and to detect economically valuable deposits. This data can also be used to reduce the environmental footprint of mining operations anywhere in the world.
CHIME is strong through its collaboration with other countries and agencies. The CHIME contract was signed in 2020, kicking off the project with the satellite Prime, Thales Alenia Space in France, and the instrument Prime OHB system AG in Germany. Additionally, we collaborate closely with NASA's Surface Biology Geology mission, having similar observation objectives. Hundreds of scientists are working on this technology today, and dozens are currently involved in the project itself.
With Copernicus CHIME, we will be able to bring fully operational products to the user community to advance in all these key application areas: agriculture, food security and soil property measurements, forest resources and biodiversity assessment, raw material mapping and composition, as well as water quality monitoring in rivers, lakes and coastal ecosystems.
The CDR is a critical milestone during the development of the satellite when the design maturity is critically assessed. After this review, the assembly and testing of the satellite and the subsystem will begin, leading to a flight readiness in 2028. The launch of the first satellite will be any time after this flight readiness.
So hyperspectral imaging allows the detection and quantification of a vast number of surface properties, basically offering a treasure trove of information, of unique fingerprints which are hidden from our naked eye, and this with an unprecedented level of detail.